Hello everyone, welcome back to our YouTube channel Gurumantra Shiksha Ka Granth. I am your educator Nidhi Dua and I teach you chemistry at this platform named GurMantra Shiksha Ka Granth. So in this lecture we are going to discuss about the section C, that is your S block, P block and D block elements. We have started P block elements and we have covered till now 13th group, 14th group, 15th group part 1, and now we are going to discuss about the structures of oxides of nitrogen. There are many kinds of oxides of nitrogen. For example, as you can see here, N2O, NO, NO2, N2O3, N2O4 and N2O5. What you have to do is you have to simply learn the formula, the name of that oxide and the property of that oxide. This is the memory based slides. You have to learn all of the following. For example, if the name is dinitrogen monoxide, that is also known as nitrous oxide and laughing gas. What you have to learn? The formula for nitrous oxide, that is N2O, and the properties of N2O, that it is colorless, rather unreactive, diamagnetic and neutral to litmus. Now the chemistry of phosphorus. This is the very important topic of this video. So as you know, phosphorus is a chemical element with the symbol P and atomic number 15. We are going to discuss about the different allotropes of phosphorus. Elemental phosphorus can exist in several allotropes, the most common of which are white and red solids. Solid violet and black allotropes are also known, but we will discuss about the white or yellow phosphorus, red phosphorus and also about the black phosphorus. Gaseous phosphorus exists as diphosphorus and atomic phosphorus. Number 1 that we are going to discuss is white or yellow phosphorus. White phosphorus, yellow phosphorus or simply tetraphosphorus, that is P4, exists as a molecule made up of 4 atoms in a tetrahedral structure. The tetrahedral arrangement results in the ring strain and instability. Now talking about the properties, it has characteristic garlic smell and also this is very poisonous in nature. Person working with phosphorus develop a disease and that disease is known as jaw bone decay. In this disease the jaw bone decays and the disease named as phossy jaw. In contact with air, this white phosphorus undergoes slow combustion and this has a very unique property to emit light, and this property is known as phosphorescence. Its ignition temperature is very low, that is about 30 degrees Celsius. This yellow phosphorus or white phosphorus catches fire, giving dense fumes of phosphorus pentoxides. This is the very important point. You need to remember this point, that when you react, this phosphorus, white phosphorus radially catches fire and gives dense fumes of phosphorus pentoxide. That's why this is kept in water. The reaction is P4 plus 5O2 gives P4O10. This P4O10 is your pentoxide, phosphorus pentoxide. Yellow phosphorus, when heated at 240 degree to 250 degrees Celsius temperature in presence of inert gas or in presence of inert atmosphere, this yellow phosphorus will convert into red phosphorus. Its structure we will study later. Next type of phosphorus is the red phosphorus. Red phosphorus is formed by heating yellow phosphorus between 240 to 250 degrees Celsius in presence of inert gas that we have studied in this slide. Its structure is regarded as a polymer consisting of a chain of P4 tetrahedral linked together by covalent bond. the structure of red phosphorus is regarded as a polymer, and that polymer contains P4 tetrahedral linked together by covalent bond. Red phosphorus is one of the most common allotrope of phosphorus, and it is considered to be derivative of P4 molecule. That you can see here, P4 tetrahedral structure. It exists in amorphous non-crystalline network of phosphorus atoms. It is found to be more stable than white phosphorus. You have to memorize this point, that this red phosphorus is very stable, is more stable than the white or yellow phosphorus. The main source of phosphorus are milk and meat, especially chicken, pork and organ meats. This is about the phosphorus, not about the red phosphorus. Now the black phosphorus. So black phosphorus is the only form of phosphorus whose structure is definitely known. You have to remember this point. This black phosphorus is only form of phosphorus whose structure is definitely known. It is the crystalline in nature and consists of a corrugated sheets. Black phosphorus is the thermodynamically stable form of phosphorus at room temperature and pressure, with a heat of formation of minus 39.3 kilojoule per mole. This black phosphorus was first synthesized by heating white phosphorus under high pressure. When you heat up white phosphorus at 230 to 250 degrees Celsius, you will get red phosphorus. But when you heat up white phosphorus under high pressure, approximation 12,000 atmosphere, you will get black phosphorus. In the structure of black phosphorus, each phosphorus atom is covalently bonded to each other three neighboring atoms. As you can see here, if we take this phosphorus as a central atom, this central atom of phosphorus will be bonded to three other phosphorus atom. As you can see here, 1, 2 and 3. For another example, if you check this phosphorus atom, this central phosphorus atom will attach to three more phosphorus atom. As you can see here, 1, 2 and 3. Black phosphorus has an orthorhombic pleated honeycomb structure, as you can see here, and is the least reactive allotrope. You have to memorize this point. Most stable form is red phosphorus and the most reactive form is black allotrope, black phosphorus. If you talk about the order of density and melting point in between the different allotropes of phosphorus, the black phosphorus will have the highest, the more density and more melting point as compared to white phosphorus, and its melting point is also least. So you have to remember this order. This is also your PYQ of GATE exam. Next, the comparison between white and red phosphorus. We will compare the white phosphorus and red phosphorus. If you talk about the properties, different properties, the most important properties I will highlight, but you have to learn, you have to read all the properties. So number 1 is the physical state. White phosphorus exists in softy waxy solid, while red phosphorus is your brittle powder. Talking about the color, white phosphorus is white when pure, but after some times it attains yellow color, while red phosphorus is of red color. Talking about the odor, the white phosphorus is of garlic-like smell, gives garlic-like smell, while red phosphorus is odorless. When you solubilize white phosphorus in water, this is insoluble, while red phosphorus is also insoluble. So this is the most common property of white phosphorus and red phosphorus. Solubility in CS2, white phosphorus is soluble, while red phosphorus is insoluble. Physiological action, this white phosphorus is poisonous and red phosphorus is non-poisonous. Chemical activity, this is the most important point. White phosphorus is very active and red phosphorus is less active. Stability, white phosphorus unstable while red phosphorus is stable. Light emitting tendency, this white phosphorus will glows in dark and this red phosphorus does not glows in dark. Reaction with NaOH. When you react white phosphorus with NaOH and alkali, this will evolve phosphine gas, pH 3, while red phosphorus do not give any reaction with NaOH. Molecular formula for white phosphorus is P4 and in case of red phosphorus this is complex polymer. So this was all about the different allotropes of phosphorus. The white phosphorus, red phosphorus and black phosphorus. You have to remember, you have to memorize this slide. This is very important slide. Next is the compounds of phosphorus. So basically we will discuss two compounds of phosphorus. Number one is phosphorus trioxide and number two is phosphorus pentoxide. So we are going to discuss about the number one phosphorus oxide of phosphorus, that is phosphorus trioxide. Phosphorus trioxide is the chemical compound with the formula P4O6 or P2O3. It is a white waxy crystalline and highly toxic solid with garlic odor. If we talk about the preparation method of preparing phosphorus trioxide is formed when phosphorus is burned in a limited amount of air. This is very important. To prepare phosphorus trioxide, you have to burn phosphorus in a limited amount, in a limited supply of air. And the reaction is P4 plus 3O2 gives P4O6. You have to remember this reaction. I repeat, P4 plus 3O2 will give P4O6. That is your phosphorus trioxide. Phosphorus trioxide on reacting with water will form phosphorus acid, and on heating in air it will form phosphorus pentoxide. This is very important. And also P4O6 is a ligand for transition metal comparable to phosphite. This point I repeat, P4O6 is a ligand for transition metal comparable to phosphite. This point we will study in the next topic, that will be your coordination compound. Next is the structure. Each atom of phosphorus in P4O10 is present at the corner of tetrahedron. Each phosphorus atom is covalently bonded to 3 oxygen atoms and each oxygen atom is bonded to 2 phosphorus atoms. You have to remember this point. Each phosphorus atom is covalently bonded to 3 oxygen atoms and each oxygen atom is bonded to 2 phosphorus atoms. So now this is very clear from the structure that 6 oxygen atoms lie along the edges of tetrahedron of phosphorus atoms. Next is the phosphorus oxide, phosphorus pentoxide. Phosphorus pentoxide is a chemical compound with molecular formula P4O10 with its common name derived from its empirical formula P2O5. I repeat, it is a chemical compound with molecular formula P4O10 with its common name derived from its empirical formula P2O5. This white crystalline solid is the anhydride of phosphoric acid. You have to remember this point. This phosphorus pentoxide is the crystalline solid and it is the anhydride of phosphoric acid. It is the most powerful desiccant and dehydrating agent. If you talk about the preparation method for preparing phosphorus pentaoxide, it is prepared by heating white phosphorus in excess of air. To prepare trioxide of phosphorus, what you have to do? You have to give less amount of air. But for preparing phosphorus pentaoxide, you have to give excess air. If we talk about the properties of pentaoxide, phosphorus pentaoxide is a snowy white solid. It radially dissolves in cold water, forming metaphosphoric acid, that is HPO3. This is HPO3. While when you react this phosphorus pentaoxide with hot water, this will give phosphoric acid, that is HPO4. These 2 points are very important. When you react this phosphorus pentoxide with cold water, this will give HPO3. But when you react this phosphorus pentoxide with hot water, what you will get? H3PO4. So these 2 points are the very important properties of phosphorus pentaoxide. Phosphorus pentaoxide has a strong affinity for water, therefore acts as a powerful dehydrating agent. It can extract water from many inorganic and organic compounds. P4O10 phosphorus pentaoxide is a very strong dehydrating agent and extract water from many compounds including sulfuric acid and nitric acid. If we talk about the hazards of pentaoxide, phosphorus pentaoxide itself is not flammable, just like sulfur trioxide. You have seen that this sulfur trioxide is flammable, but phosphorus pentaoxide is not flammable. It reacts vigorously with water and water containing substances like wood or cotton, and this liberates much heat and may even cause fire due to highly exothermic nature of such reaction. It is corrosive to metal and is very irritating. It can also cause severe burns to the eyes, skin, mucous membrane and respiratory tract, even at the very low concentration. So these are the hazards of phosphorus pentaoxides. Now about the structure of pentaoxides. Phosphorus pentaoxide crystallizes in at least 4 forms of polymorphs. The most familiar is your metastable form, and its structure is similar to that of P4O6. In addition, each phosphorus atom forms a double bond with oxygen atom. Only the difference came, the phosphorus atom will form a double bond with oxygen atom. So this was all about phosphorus pentaoxide. Now the most important types of polymer, that is HPO3 whole thrice. What you have to do is you only need to learn the name of these 2 polymers of HPO3. Number 1 is the polymer of metaphosphoric acid. For number 1 polymer is cyclotrimetaphosphoric acid, HPO3 whole thrice. This is the number 1 type of polymer named cyclotrimetaphosphoric acid. And number 2nd is HPO3 whole N, that is polymetaphosphoric acid. This is the polymer HPO3 when attached in a chain-like structure. This will form polymetaphosphoric acid, as you can see here in this diagram. Only you have to learn the names of these 2, HPO3 whole thrice and HPO3 whole N. I hope you all are cleared about the allotropes of phosphorus and the different oxides of nitrogen. This was all about group number 15 elements. Now, in case if you are new here at our YouTube channel GurMantra, please do like, share and subscribe. And if you have any query, you can mail us on tanejanehaofficial@gmail.com, or you can also contact us on the given number. Now there is an important announcement. If you are an aspirant of CSIR NET UG, you can follow Neha Taneja ma'am on Unacademy. She is the one of the best educator over there. On Unacademy platform, you will get daily live classes, structural courses, live tests and quizzes, and with one subscription, you will get unlimited access. If you are interested in this course, there is also a detailed paid classes. You can go through with this detailed paid classes. While taking the subscription, you can use referral code NEHA. You will get 10% discount after using this referral code on the total fees. Thank you very much guys. I hope you liked the video.